atomic clock, maybe.
It's an interesting thing because, I mean, think about where do they all get their one from, and then where do those ones get theirs from? And if one is off, are all the other ones going to go off? Or
I would only assume so because they all have to synchronize and adjust to the skew to synchronize with that one single time server.
Well, whatever the root is, it has to propagate, probably broadcast out.
Yeah, they have complicated algorithms to account for the propagational delay. So that way, they do a ping and they try to measure how much time is delayed and then they account for that as well. So by the time you have the actual time on the computer, it is actually pretty accurate. Like, in this case, since I'm using Linux, this time is actually, accurate down to the second. At least down to the second, because that's the only part I can easily verify using my eyes. But the kernel automatically goes out to the time servers and find out, okay, what is the current time? If my clock is skewed, how skewed is it? And it will try to even maintain, that information so that it will keep track of time correctly, locally as well. Sorry?
There's a lot to that.
There is a lot to that. Yep. Yep.
I wonder if they have the algorithm out there.
Yeah, I'm pretty sure that it is already out there. It's probably one of those RFCs, like a proposed, standard thing, and the algorithm is already well described, as is the protocol, to talk between the time servers and the client. Right. So back to the homework assignment first. Okay. So I finally figured out, why it is doing what it has been doing. I mean, thank you to all of you who reported the problem, but I couldn't quite figure out why it's doing it until last night. And I really took a much closer look at what it's doing, and go like, that doesn't seem to make a lot of sense. So what happens is this, and I'll try to draw a picture instead of using the whiteboard so it can be recorded. And I will be checking on the recorder occasionally just to make sure that it is not crapping out on me.
Mic working?
Mic is working.
Mic recording?
Pretty sure. Yep. So mic is working, and here comes the door. Good job. And so so what we're going to do is to take a look at the homework assignment. I'm not going to do the homework assignment for you, but I will illustrate enough concepts with the sample program, and you will have to incorporate those things into your own program to make it work. Okay, so that's what we're going to do today. So I will start a new project, just for the illustration of how to use sprites and how to use the rotation correctly with sprites. Okay, so we'll just call this, project name. We'll call it arrow. Okay, or yeah, arrow is fine. Okay. All right. So here's an application where I will make it as simple as possible, just to illustrate the concept that I want to illustrate. So it definitely needs a canvas, and we'll make the canvas, well, the size does not really matter. So I'll just make it fill the parent instead of the width, and in terms of the height, we'll just pick 300 pixels, kind of like your project. We go. So now we have the canvas, which is where the sprite is going to live in. So here comes the image sprite. I'm not going to even bother with a ball sprite because whatever applies to an image sprite also applies to a ball sprite, except with a ball sprite, it doesn't matter how you rotate it, it still looks exactly the same. Okay. So the one thing I want to do is to use a image that is kind of really kind of extreme in terms of its width versus the height. Okay, just so that it is a little bit more arrow picture, and hopefully, yep, there we go. So now we have a lot of choices in terms of which arrow we want to use. We can pick, let's say this one. So we'll go to the image and just copy the image and put it into the GIMP. Oh, and the graphics. The GIMP is is really a fantastic program for basic stuff with images. So you can actually just create an image from the clipboard. So there's no need to copy and paste and all that stuff. You just say, okay, I want to create it from the image from the clipboard. And this one already has transparency. You can see the background is kind of checkered. that means it is transparent. That portion is transparent. So I'm really good to go. Except the size is a little bit too big. I can downsize it a little bit. So I can go to image and go to scale image. I can downsize it to, this time I don't want to downsize it too much because otherwise it won't illustrate the effect as much as I want to. So we'll downsize it either based on width or height. So I can adjust one or the other one, and this link means it will adjust the other one accordingly. So the scale will still be, not the scale, but the proportion will still be right. Or they call it aspect ratio will still be right. So in this case, let's make this one, let's say 50 pixels, 50 by 66. We can make it a little bit bigger. Okay. So we have a pretty big bitmap here, and I'm going to use the entire thing for my sprite. So the effect will be kind of visible, because if it's too small, it's not going to be as visible. So we'll do the scaling, and we can save the file or export the file to a folder. I'll just export it to my temp folder. We'll call it arrow.png. Make sure the save background color is checked, otherwise the transparent background would not be checked. And save gamma is also important to save anything that has transparency. And that's it. That's all we need to do. Export, and now we are done with the GIMP. And I'm going to close the GIMP, discard the changes, and now we can get back here, upload the file, upload the image file, which is in my temp folder. It's called arrow.png. And the file is now uploaded. And then I go back to my sprite image, my image sprite here, and change the picture to the arrow. And as you can see, the arrow is pretty big, okay? But that's exactly what I want to illustrate the point that I want to make. Okay, the first thing has to do with where is the XY? When you say move to a certain location, like XY, what is the exact location? You can tell right here. You don't even need to write a block of code. Right now, the X coordinate is 70, the Y coordinate is 109. So if you just move this thing around in the canvas, it will update this number accordingly. Okay, so you can actually tell that over here we have X and Y being kind of the maximum, but it's not really the maximum, because remember, the width of the entire canvas is almost 300 pixels, and the height is certainly 300 pixels. So that means, oh, it has a little snapping thing going on here. That means this corner is actually the XY coordinate of the entire image. Okay. So now we will go ahead and say, okay, if without changing X and Y, let's do some rotation and see what happens. You have to make sure rotate is checked here, otherwise the image itself is not going to rotate at all. And we'll change heading, and let's just make it 90 degrees so that it points up. Okay, that doesn't update the screen, but we can do it in the application. Okay, so we'll just stick this one all the way here without changing the XY coordinate. Do it. It doesn't, whatever reason, I cannot snap it to the position that I want. There we go. I think it has to do with which corner I'm grabbing it. If I'm using the upper left corner to grab it, it will drop it to exactly the place that I want to drop it. If I pick anywhere in the middle, it's not going to drop it correctly, because it's always saying the drop point is the upper left corner. So that's the reason why it's doing that. So I have to kind of move this one all the way, or just use this as a grab point to grab it and put it here. Okay. So the next thing I want to do is to do some rotation and find out, okay, how is it going to be updated with rotation? So to do that, since it won't update this preview window, which kind of makes sense, because that part depends on the code. I'm going to start the emulator, get the program to run first, and then we'll do some rotation and find out whether the rotation changes the XY coordinate. Okay, and the answer is no, it does not. Okay, because the XY coordinate applies to the upper left corner of the image sprite before rotation. Okay, so any rotation after that does not really change the XY coordinate. So we'll take a look at this one and wait a little bit. And there's a perfect explanation why many of you have reported the problem of, hey, it's not pointing to the direction of where it's supposed to, even though I got the code right, it's still not pointing correctly. And how do we fix that problem? So I'll have the solution to all of that stuff just a little bit. So has anyone planned on dressing as an android, for Halloween?
I've seen one yesterday driving down the street.
Yeah.
Some guy dressing up as an android.
Yeah, I think in previous years, Minecraft was really popular. I think this year maybe that's not going to be as popular anymore. People dressing as creepers and all that. All right, so here is my arrow here, and going to blocks, I'm going to change just the rotation without changing the XY. Okay, and we'll go ahead and use a timer so that it keeps rotating, so that way it is more effective to demonstrate what is the center of the rotation. Okay, so we'll go to, I think under sensors is clocked, and this time I'm not going to do too much with the clock. We'll make it always fire enabled, and the timer interval we can just make it let's say 50, so it updates 20 times per second. And then we go to blocks, we go to clock 1 and say when there's a timer tick from clock 1, do the following. The image sprite is going to do something. All it's going to do is to do some rotation. So we'll just go ahead and change the heading only without changing the coordinate, the X or the Y. We'll set the heading to whatever the heading was, and then plus, let's say 5 degrees. So with each tick, it moves a little bit, and then because it's moving, it's updating 20 times per second. So in 1 second, it will update 100 degrees in this case. So now we have to do some math. Simple addition will work. So we put addition here, and then we put the current heading into one of these slots here. So we go back to the sprite, we grab its current heading, which is image sprite 1 dot heading, and put it into the first slot here. And then the second slot, I just need to have a constant of, let's say 5 degrees or 10 degrees. Well, 5 degrees would be good. So I'm gonna put one here, change this number to 5 degrees, and the application should be running actually. Okay, so can anyone kind of point out, what it is rotating around?
Center.
The center. Okay, it's rotating around the center of the image sprite. But the XY coordinate has never changed. So that means the XY coordinate has always been here. Okay, which is where it started originally, and it's rotating around its center, which is about here or so. Are we doing okay so far with this picture? Okay, so that tells you something already. And then the alignment, when you use point to, okay, you're making an image sprite to point to a certain location, it is using its center axis as the alignment line, and that is why we have a problem with only moving the image sprite and then make it point to a certain XY location. Okay, let me go back to this application here, and basically describe what it is using to adjust its axis. What axis is being used to do the pointing part. Okay. So let's go back to the designer here. So this time, what I will do instead is, I'm going to put this one, all the way to the center of the screen. Well, just close to the center. It doesn't have to be exactly the center. But this time, I want to draw a line from the center of the image sprite to a certain location. All right. So I have this coordinate here. This is just the regular XY. When you go to a image sprite X and image sprite Y, that is the coordinate. We know the height of the image sprite at any time because it is reported as a property, as well as the width at any time as a property. So can we calculate the center, the pixel or the coordinate of the center of a image sprite when it is displayed in a canvas? Okay, so let's go ahead and do something right there. So what I want to do is, well, let's use some local variables because we don't want to have to recalculate things over and over again. So I'm going to use this block here. This block allows me to use certain local variables that is not visible outside, and they don't even exist outside of this block. That's one good thing about local variables. So I would just say center x as one local variable, and we'll go ahead and make another one. I'm just dragging and dropping the other block here to make a second variable called center y. So we'll call this one center y. So with center x, I want to calculate the center of the entire image sprite. So that means it's going to be a calculation. The problem with a calculation in App Inventor is you have to kind of plan out the whole thing first. Otherwise, you'll be doing a lot of dragging and dropping and changing it later on. So we'll go ahead and grab the things that we need anyway, okay, and then we'll find out how to combine those things. So we go to image sprite and go to its properties. It has x and y down here. So we know that we need to know the current coordinate of the upper left corner of the image sprite, because that's the only point that it is at that point. So we know that we need this one, and also the y coordinate. The x coordinate, it really just kind of changes, whether one is overlapping the other one, which one is closer to you. So it's not as important in this application. So we need the x and the y, and we also need the width and also the height of the image sprite. So we go to image sprite again, and this time we grab the width and also the height. Okay, so here's the height here. All right. So once again, how do we calculate the coordinate of the center of the image sprite? Let's just focus on the center along the x-axis. How do we calculate that? We know it has to do with this guy here. We know it has to do with this guy here. And we also know that it has to do with something with addition, because you have to combine these two numbers. And there's also one more thing that we need to know, because remember, the width refers to the entire width of the image sprite, but the center is only halfway through the entire width. So that means we need to do a division by 2, divide by 2. So we also need to go to math here and grab a division block like that. Okay, so now we have all the blocks here just to do the center along the x-axis. We know this has to be on one side of the addition. We know that we have to divide the width by 2, so we'll go ahead and put this here. And if I just select the entire block and type 2, it will automatically go to the block that is currently empty and unfilled. Okay. And this is all we need to do. Okay, you just need to refer to the current x coordinate of the upper left corner of the image sprite and add half of the width to that x coordinate. That becomes the center of the entire image sprite. Okay, so we'll put it here. And to calculate the y coordinate, it's about the same. So while I'll just be lazy and just duplicate this block here, stash it here, and change the x to the y, change the width to the height, and then we have the center of the entire image sprite. So these two are no longer needed in my calculation. Are we doing okay so far with this? Is that okay? All right. So if that is okay, we need to kind of verify that really is the case. That really is the center of the entire thing. So what we'll do is we'll draw a line from the center and then use the heading to control where the line is going to. So now we have to go to canvas, because the image sprite itself cannot draw a line. The canvas can. So we go to canvas, and then we can see that it has let's see, it has several fancy ways to do stuff. Draw text at angle can be helpful. It's draw point, draw line, draw circle. it doesn't have one way for me to draw a line based on the origin and an angle and the length of a line. So what we'll do is you guys, do you still remember your trigonometry? Sine, cosine, that stuff? Maybe a little bit? Okay. Well, that stuff is useful. I mean, that really is useful stuff. Let's go ahead and just use draw text first, and an angle, because that's the easy one to use. So we'll pick out this item. Let me see if there's anything else I can draw at an angle. No, not really. Okay, so we'll just go ahead and do the draw text at an angle. This is going to be in the background, not in the foreground. I'm just thinking out loud, how to make this kind of obvious. Okay, I know exactly what to do. We can use draw line just fine. Okay, there we go. When we use a draw line, we'll draw lines from the center to. Yeah, I know. So we'll pick the center to be x1 and y1. And then the x2, y2, will be, based on center x. We change one without changing the other one. So, thank you. So we'll just go ahead and duplicate this one so that we keep the same x. So we're just basically drawing a horizontal line in this case. Oh, I get it. It's because the program is already running and it's constantly trying to recompile. Every time I do any changes, it's recompiling and complaining. Oh, it cannot work. Dismiss. So I just have to stash something here so that it doesn't complain. No, go away. Okay, so we'll use a addition. And we'll grab center Y. And we'll give it a, just an offset so we can see, a line segment. Try 150 pixels, and that should be enough already. Okay, that will point out where's the center as far as the y-axis is concerned. So when we switch to the emulator, you can see the center as long as the y-axis is concerned is here. So I can do the same thing about the x-axis, and you probably will already kind of guesstimate that it will be around here. Okay. So are there any questions about the coordinate system of a image sprite, how to place it, and where's the center? Now this is the issue. Okay, the issue has to do with the direction is along a line that is through the center of the image sprite. So, but the coordinate of the image sprite is not based on the center line. It is based on the upper left corner of the image sprite before rotation. So when you try to point it to a certain location that is really close to its own upper left corner, it's going to flip back and point to its, point to that location. Okay, and that's the issue. I can draw that, with a whiteboard, probably a little bit better than using this one here. So let me go get a marker, if I can find one. Let's see the hard one.
Yeah.
Yep, there's one here. Okay. So, as far as the image sprite is concerned, okay, let's say this is my image sprite. Now, the image sprite has basically an invisible rectangle that is its boundary. Okay. So within the boundary, this is the width, and this is the height of the image sprite. The x and the y coordinates of the image sprite refers to this point here. So this is x and this is the y of the image sprite. The center of rotation is at the center right here, which is at w divided by 2 and x divided by 2, which is right at the center of the entire thing. when you say point to a certain location, it is not going to form a line from here to wherever you want to point to. It is going to form a line from here, the center of the entire thing, to whatever you want to point to. So let's say the next point that you want to point to is only at a slight angle to here. Is that okay? So this is your new xy, so we'll call it x1, y1 here. And this is your new coordinate. So you would think that the image sprite would just change direction a little bit like this to align to it. But that's not what it's going to do. Because what it wants to do is to use the center and say, oh, okay, let's rotate from the center's perspective so that it would point to the new x1, y1. And that's why the entire image sprite is going to rotate this way and point to that point instead of doing it like this. That is the one. That's the reason why we are seeing what we are seeing when we use the point to image sprite point to block. It's just not going to do it. Okay. So to illustrate this point here, I can just go ahead and make my program a little bit simpler to illustrate it. Yep. Row sheet is right here. I think somebody just stepped out for a phone call. Yep. All right. So what we'll do is we'll change this program and we'll disable the clock. Okay, we don't want the clock to do it automatically anymore. So we'll disable the timer and it should stop rotating right now. Yep, there we go. And instead, I'll just use one single button to kind of illustrate that point, okay? So we'll go ahead and use one single button to illustrate that point. And so I don't really need a button. I can just touch the canvas, but using a button just kind of feels better. Okay, so I'm going to use a button here. And in the code, all I'm going to do is, so let's go to button 1. When button 1 is clicked, the only thing I'm going to do is not to move the image sprite itself, but to make it point to just a little bit off from where it is. So I will go to image sprite and say point in direction of some xy. But this xy is going to be just a little bit of an offset from the xy coordinate of the entire image sprite. So I go to image sprite again. This time I grab the x and the y. So we have x. And I can just duplicate this block here because I can get to y easily by doing that. But I also need a slight offset, so I just go to math here and use the addition block. And we'll have image sprite going here. And we'll just add a very small number. Okay, let's say 10 pixels. Okay. 10, enter. I'll do that this time. 10, enter. There we go. And as far as the y is concerned, let's do about the same thing. So we'll go ahead and just duplicate this block here. And this time we'll select the y coordinate instead. Okay, so let me just give you the code here. So the code is really just saying, okay, let's go ahead and make the sprite point in the direction of 10 pixels to the right hand side and take 10 pixels down, okay, because the y coordinate is a little bit misleading. 0, 0 is all the way up at the upper left corner, and then the maximum is down, at the lower portion of the screen. Okay, so let's go back to the application. So in this case, in the ideal world, it should just point down here, okay, diagonally down to the lower right-hand corner, okay, because that's where the point is, okay, from where it is at this point. But when I click this button, it's not going to do that. Instead, it will actually point up at an angle. Okay, let's double check that first. Okay, and that has to do with exactly the problem that we were describing here. So in the case of our application, my new xy is down here, off by 10 pixels, down, off by 10 pixels to the right hand side. So even though in terms of from x1, in terms of the origin of the entire image map, and the new point should be pointing down in this angle. But because the angle is calculated from the center of the entire image map, it now points this way instead. So that explains, why we are observing what we have been observing. Okay, that's the problem. That's the issue. So now the question is, how do we fix this problem? And some of you probably have noticed the drawing is not, at the center of the line. Okay, the image sprite is actually off a little bit from the center of the line. So we want to fix both problems at the same time. And to fix both problems at the same time, we have to basically do all the calculations based on the center of the image sprite and not based on the upper left corner of the image sprite. Is that part okay? Sort of? Okay. All right, so let's go ahead and see what we can do about that, okay? So given that we want the image sprite center to be at a location, how do we specify, how do we move the image sprite to that one location? Okay, that's what we want to do. And I'm going to do the same thing with this application here, but this time I will use a touch down and a touch up on the canvas itself to control where I want the center of the entire image sprite to be located at. Okay, I'll do it wrong the first time, which is just grabbing the XY coordinate of the touch and move the image sprite accordingly. So that will be the wrong thing to do, and you will see that the image sprite is not supposed to be there, and then we'll fix that problem. Okay, so the fixing of this problem is the part of the solution to your homework assignment. So we go to canvas, and then we say touchdown. We take the touchdown event handler. This X and Y refers to the point where I'm touching. Okay, so I would do it wrong the first time by saying, okay, let's go to image sprite and change its own XY accordingly to just the XY of the touch. So we go to set image sprite 1.x and duplicate this block to control the Y to just the XY of the touch point. Okay. Oops, not this one. Get Y goes here. Okay. So now when I go back to my application and I click somewhere on the screen, you can see that that is just controlling. Whoops. Uh-oh.
Oh.
It just crashed. So I have to go fix that first. I'm just curious, how many people are using the emulator to write your program? Few, okay. So the rest of you are using your own devices? Is it faster and more convenient that way? Okay.
Sometimes.
Sometimes?
I use both.
Okay.
I use a program called Software Data Cable, and then basically it allows me to use FTP to basically copy everything over as I build it.
Mm-hmm.
Works pretty nice.
Okay. We're getting there. Do you guys experience this kind of crashing problem in Windows? Okay.
Yes.
All right, so I'm just going to click here. There we go. And you can see it's just moving the upper left corner of the image sprite to those places. Is that okay? Okay, so the next question now is, how do we fix this program so that wherever I click, it's going to move the center of the entire image sprite to that location? And how this relates to your homework assignment, I will leave it up to you to decide, okay? Because that is something that you have to think about. Okay, so we know this is not going to work, okay? We know this X and Y is a good starting point, but it's not exactly where we want it to be. So we'll take this out, okay? Yes, it's going to give us some warnings, but that's okay. So we know this is a good starting point, but it's not where we want it to be exactly. So we have to do some math. In other words, now the problem is I want the center of my image sprite to be here. If I just change the x and the y coordinate of my image sprite to be here, then it will just move the entire image sprite to here, which is not what I want, because the center is over here. I want to move the center all the way back to that point. So the amount that I have to move is based on half of the width and half of the height. Okay, I have to subtract 1/2 of the height from the y coordinate and subtract 1/2 of the width from the x coordinate in order to make the center appear at exactly this point here. Okay. So now we have to do the math. It involves subtraction and division by 2. So we go to the math blocks here and grab those things. So we'll grab a subtraction. We'll grab a division. This is where I really do not like the way App Inventor does things, because it's something that it could have entered easily by typing, but by doing it this way, it is a little bit more involved. Not too bad. Okay, so now we go back to image sprite 1, go to its x coordinate, and specify division by 2. So select the whole block, type 2, press enter. Sometimes it works, sometimes it doesn't. I don't know why. Now it works. Okay, so now we move this entire block back to here and have that one problem fixed. We'll put it here. Duplicate this block and put it here, and then we'll change x to y and change image sprite 1.x to image sprite 1.y. Division by 2 is fine in either case. And this is the fixed program. Let's go ahead and give it a try and see if it works. Go to the emulator and pick a new point. So this time it is, it's not moving the center. I'm clicking the same point again and again, and it's not the center. It's doing the averaging. You can see it's doing some kind of averaging to get to the point.
Shouldn't it be image sprite?
Oh, yeah, right. I got it right. I said the right thing, but then when I wrote the code, I picked the wrong thing. So this is the width, and that would be the height. There we go.
Oh, there it goes.
Got the concept right. When I coded, I got the code wrong. There we go. So we now move the center of the entire image sprite instead. Okay, is that going to help with your homework assignment? Yes, it will, because now the path that your image sprite is moving is going to be along the center of the entire image sprite, so it will look right. Is it going to fix the heading of the image sprite? Not really. Okay, so to change the to fix that problem, you will have to use something else. You will have to use the arctangent feature of the math library of App Inventor. Okay, so this is a good time to kind of talk about what arctangent does. Arctangent 2 is actually a very, very handy feature. It is a lot easier to use than just regular arctangent from the math class. The regular arctangent in a regular math class cannot handle certain values, but this one can. Okay, so let's go ahead and just kind of go through some basic concepts in terms of what is tangent of a line. So this is a line. This is an angle. We call it theta for whatever reason. They like to use Greek letters to refer to angles. So if you draw a line here, then we have a base. Let's call this x, and we'll call this y. The tangent of theta in this case is just the ratio of y divided by x. Okay, So arctangent is basically taking the ratio and coming back with the angle itself. In other words, if you want to do it, in the opposite way, theta is the arctangent, and arctangent in math is written as tangent with a negative sign, negative one on top of it, because it's the inverse function, the reverse of the operation. Okay. So it is also known, to most people, known as arctangent as atan, and this is y divided by x. Okay. But there are certain angles where this theta cannot be calculated. Okay. Like when it is right here, then there's a problem. Because now at this point y is just a certain length, but x is 0. So you have a division by 0 problem. Now arctan2 in App Inventor can deal with this problem. It will just return, oh, that's 90 degrees, no problem. So that's why arctan2 in App Inventor is really handy. It really fixes all the problems that we have to deal with. Okay, so now we go back to this application and say, okay, press down, when I touch down, it will control the center, but I can drag it, and when I touch up, it will change the heading to where the touch up event is. Is that okay so far? Does everybody understand what I'm doing with this application? So touch down changes the location of the image sprite, using the center, and then touch up is going to make it point to where I let go of the touch. Okay, so this way I can illustrate how to use that particular feature. Okay. So going back to the blocks here, the first thing is to do it wrong first. Okay, so the first thing that I'm going to do is to do it wrong and use the laziest approach possible, which is actually incorrect. So go to Canvas and use touch up and say, well, let's do it the simple way. Okay, the simple way, which is also the wrong way, is to go to image sprite 1 and use point in direction and say, oh, okay, we'll just grab the x from touch up and grab the y from touch up, and we're all done. Okay, so we'll go ahead and see whether this works or not, and if it's not working, how is it not working? So touch down is still changing the center, and then if I use a touch up, hey, it's working. Tag, what is the big deal of this not working? Okay. Do you know why it's already working? Because it is already based on the center. Okay, so there's actually, with the fix of the coordinate of the image sprite, there's no need to fix the point 2 angle anymore. So the arctangent is only necessary if you're not changing the coordinate of the image sprite. So this is actually kind of a good news. You have to fix one place or the other. So you either have to fix the move to block, or you have to change the point to block. Okay, because the point to block is not going to work if the coordinate is based on the upper left corner of the image sprite. But in this case, I already fixed the coordinate of the image sprite so that the point that I want it to be located at is the center of the image sprite. Is that doing okay so far? In other words, I have already fixed the problem without using arctangent 2. Is that kind of okay? Does everybody kind of know how to fix your program so that it would look right? Yes, sort of. Sorry? Okay. I'm gonna make this program available to all of you, so you can play with it, you can change the image here, and you can definitely tell that it is completely working now. So even if I touch up inside the length of the image sprite, it's still working just fine. Okay, this is a touch down, and here I have a touch up, and you can see it's just adjusting very slightly to make it align to the new point that I'm touching up. Okay, so let me go ahead and save this program and upload it to Moodle right away, because otherwise I tend to forget. This is called Arrow, and I'll export this to my computer first, and then upload it to Moodle. And I will put it under drawing in 2D because it is a canvas related type of thing. So I'll put it right under directional tracker. And it's a file. I think I put it into the downloads folder. There are no easy ways to copy code from one project to the next, so you will have to kind of reconstruct the blocks a little bit. But it's not too much work. I mean, that really is not. All right. So that should help with your homework assignment. And as I said, I postponed the due date for 24 hours, so you have, basically another 24 hours to work on it. All right. So with that one done, we're going to go back to activities and intent, and I have, basically finished this entire slide of how to connect two App Inventor applications. So what I do want to do is this is something that we figured out last time, is to specify app_inventor_start for extra key and specify app_inventor_result for result name. So in order for one App Inventor app to pass a value to a second one, you have to use the first one, and then to get it back, to get a result back from the other application back to the requesting one, you need the result name with this value. So this is what we figured out last time. So what we'll do instead today is to talk about the client server model, which is actually not uncommon these days with programs and also with all sorts of applications. The concept of a client versus a server is something that you do at a restaurant already. Okay, the person who's doing the request and ordering food and asking for more water, coffee, and whatnot is the client. The client makes the request. The server, on the other hand, is the person who is responding to the request. Okay, so that's the same model with applications, with networking, and all kinds of other stuff related to computers. The client refers to the party that is making the request. The server is corresponding to the party that is responding to a request. Are we doing okay so far in terms of the client-server terminology? So with that terminology out of the way, this is kind of helpful because we can now have a single server application that can respond to requests from multiple clients. In other words, you can write several applications. I'm going to use the whiteboard to kind of illustrate this concept because it's a lot faster using the whiteboard to illustrate this. So let's say that you have one single server application. It can be written in App Inventor, it can be any concept. But the server, there's only one server. But then you have C1 as a client, C2 as a client, and C3 as clients. So in this case, in this context, these are all apps. C1, C2, C3, and server, they are all apps. And they can all be written in App Inventor. Okay? So the model is C1, C2, and C3 are client applications. And then server is a server application. So now you can design your applications where the bulk of the logic of all the background stuff that needs to happen is over here. C1, C2, and C3 are the front end, so they have all the buttons, all the fancy stuff, canvas, sprites, and whatnot. So when C1 needs to get something done that server can do, then you can make a request and say, use activity starter, in this case, use an activity starter component and say, hey, server app, I need you to do something for me. Okay? And you can send a start value that server can grab and say, oh, okay, I can see that you want me to do blah, blah, blah. When server is done as an app, it will close the screen, but at the same time, it can pass a value back as the result. Now, when you have another application, let's say C2, you can also do the same thing here. Another application C3, you can also do the same thing here. So C1, C2, and C3 can be just basically front ends of whatever server is really providing, or they can make different use of the resources the server has access to. Okay. Now there are other things that is kind of interesting in this case, because if there's only one server and server itself is interacting with TinyDB or remote database, doesn't have to be local, then you can have C1, C2, and C3 eventually basically all accessing the same database, which can be a handy feature, okay, depending on what your app is doing. This can be a handy feature. You can kind of imagine that one app can be for different people, okay, for different roles of a particular company. Maybe the manager will be installed with C1, an employee, or a frontline manager will have C2 installed, and a sales staff, on the floor will have C3 installed. Okay, but they all interact with server. The server app will contain the logic and all the complicated stuff to talk to a corporation server, so that the manager has access to just about everything. The frontline manager has access to certain things that the employee or the floor sales person may not have access to, and then the salesperson only has access to certain things that has the most limited access to the server. But this way, you don't have to replicate all that logic over and over and over again, because the server, which contains the actual logic to talk to a TinyDB, or in this case probably a remote database, that can remain exactly the same. Am I making any sense at this point? Okay. So with that out of the way, the next question is, can we make the server app so that it doesn't pop up a screen, because it's kind of distracting? And the answer is no, not in App Inventor. Okay, because in App Inventor, every app that you write has a screen one. Okay, and there's no way around it. Okay, when you start another screen, when you start another activity, the term activity itself in the Android terminology is a screen. Okay, so when you start an activity, there will be another screen. So you cannot make a screenless server app not in App Inventor. However, there is a way to kind of make it minimize the distraction. So what you can do is, if the server app does not need any type of end user interaction, I should make it very clear, it is not end user interaction, because it can still interact with network resources and some other stuff. It's just that it does not need to talk to the end user. So what you can do is you can make a default screen, and it doesn't do anything except it shows a message and say, please wait while the request is being processed. Okay, so it will show that screen until the thing, whatever you want to calculate or whatever you want to process is done, and then it will close the screen and get back to the requesting application, or the requesting screen, I should say, because it's all screen based. Are there any questions about this part here? Making your server app as non-distracting as possible, basically. No questions? Okay. You also want to kind of look into structured request and reply, in case you want to do something like this. And we talked about it last time already. We already have a JSON encoding subroutine, so that you can encode an entire list into just a string, and then you can use that string as the start value to the server app. When the other side is done, when the server is done and want to reply with the result of the processing, it can now reply with a list also, because that process, the server application, can also encode the result, which can be structured back into a single string, and then the requesting app, the client app, can decode it back into a structure and get all the different results back. Okay, so the JSON stuff is very applicable in this case. Here I have an example, of using a server app just to do some calculations. So in that case, the request can look like this. Okay, from the client app to the server app, you basically use a list of key and values to indicate what you're requesting and what are the parameters of that particular request. So in this case, the request type is a summation. Okay, I want you server app to add a few numbers. Okay, and then you have to supply the values. What numbers am I supposed to add? So the numbers or the values that it is adding is 1, 5, 2, and 10. So this entire list, okay, when you see the use of parentheses in this way, it is a list. So this entire list can be JSON encoded and transmitted to the server app as one single string. When the server app gets this string, which is in the form of a start value, it can decode it back into a list and then grab the request type and go, oh, okay, I understand now, I'm supposed to add some numbers. But what are where are the numbers? Okay, it is in the values, and the list after values are the values to be added. Okay, 1, 5, 2, and 10. So the server app will add it to 18 and then formulate the reply either just as 18 or it can be structured as well. But the same server app can also handle a different request. So you can format a different request, and this time you're trying to find the maximum of some values. So you can specify the request type is now finding the maximum, and then the values, in this case I just used the same values, but the result would be a 10 instead of an 18. So this makes it possible for your server app to handle a variety of stuff. Okay, you can specify what kind of a request it is and what are the parameters of that request, what additional information is needed for that request. Are there any questions about how JSON fits into this picture? No questions? All right. If a server app has multiple screens, an activity starter can start any one of those screens, because whenever you start, the term that refers to activity class, that refers to the screen name of where you want to start. So if the server app has multiple screens, you can actually pick any one of those multiple screens as the target to start. Now that is kind of handy because now you have options. Okay, there are several options to get it started. This part here talks about the workflow of writing applications in this manner. You basically start with the server app and make sure the functionality of the server app is up and running and correct before you write the client applications. But how do you test a server application if it doesn't have any user interaction? So there are suggestions here to make it work. In a server app, you can use screen 1, which is the default start screen, as a debugger or a debug trigger, and make the other screens, if you want to, are the launch points of the other applications. Within a server application, you can also use open another screen block to start another screen. So you can actually debug the logic within the server app itself. You can also use the same exact screen to land on, and then based on the start value, you can decide whether it is supposed to be interactive or not. Right? Okay, so I'll just go ahead and give you some sample code here. Okay, so I'm gonna start a new project. So I'll just say this is server app. Okay, so this is my server app. So normally, I would not do things in a very non-interactive way. So let's just say that I have got buttons, checkboxes, labels, and a whole bunch of other stuff, that is intended for user interaction. Okay. When you code it, one thing you can do is in the screen 1 initialize block here. This block activates whenever this screen is started from somewhere else. Okay, it can be started from the Android operating system. The first time you start the app, this gets triggered. But if another app is requesting a screen using activity starter, this also gets triggered. So this is the entry point to screen 1 of this particular app. Doesn't matter whether you are starting it as an end user or another application is starting it remotely, as a server app. So one thing you can do here is to use a conditional statement. Use a if then else block here. Okay, we definitely want to specify else in this case. And what you do is you check the start value. So you go to screen one. Start value is actually under control. So you go to get plain start text. Okay, that's what you need here, and you want to compare it to nothing. Okay, so you go to text and then you compare it to nothing. So let's say compare text, and this is the plain start text, and you want to compare it and see whether it is nothing. So to specify nothing, you just have to go to this block here, which is by default nothing. If it is nothing, that means you're not started by another app. So your role from this app's perspective is now saying, okay, I'm not started by another application. I'm going to get into my interactive mode. Okay, I'm not going to exit right away because nobody is asking me to do anything. I'm assuming there will be an end user using the text boxes, the buttons, the check boxes, and whatnot to tell me what I am supposed to do. Okay, so over here, it means there's really nothing to do. Okay, you get into the interactive mode. Otherwise, you specify whatever calculation you need to do, and then you reply right away and say, I'm done, and here's the result. Okay. I'm just going to illustrate using a local variable block just to illustrate the concept. You kind of have to stuff it with something that makes sense to you. Okay, but somewhere in here, you will do all the calculations, and then when you're all done, without waiting for anything else to happen, you go to close screen with plain text and pass the result back to whatever application is requesting the operation. So this way, this screen will pop up for a fraction of a second or however long it takes to finish the processing, and then it goes away. Am I making any sense? Okay. Now, if you want to make this even more fancy, in other words, if you want to make it so that if it is interactive mode, it pops up all the dialog boxes and it pops up the buttons, the text boxes, and whatnot. If it's non-interactive, you just display a simple message and say, please wait while processing is being done, or whatever you want to say. You can also do that. And the trick to do that is in your designer, you don't want to start with something like this. You want to use something to contain all of this stuff here, so you can hide and display a whole chunk of stuff at the same time. So the way to do this is to use layout, and pick one of the layouts. Most people just pick horizontal arrangement. So we'll just pick this one here, and then you can start to put things inside here, which is not going to be. Oh, okay, I take it back. Not horizontal, vertical. So we'll pick a vertical layout here, and put the same stuff back into the vertical layout, which is kind of like the default. Okay, and get rid of this one. Delete. Right. Okay, so now we have one layout, based on the interactive mode, and we'll call that accordingly. Okay, so we'll rename vertical arrangement 1 to vertical arrangement for interactive. Okay, it's just as in the blocks, when I need to specify the code, it's easier to tell which one is which one. Now you can then have another one. Okay, go ahead and make another one that is not nested within the first one, and all this one is going to say is put a label here, and all the label is going to do is to say, please wait while the system processes your request. Or whichever way you want to express that this is non-interactive. There's nothing for you to do. Just hold on, wait a little bit, it will be done soon. Okay. And depending on which one you think is going to be the default, you can basically hide one and display the other one. So let's say this is not going to be the default. You think in most cases it's not going to be interactive. You can just say not show this one. Just hide it completely. Okay. Now, what if it is interactive? What if you're not started by another application? In the blocks, you can do something about it. So in this case, if you're not started by another application, or it did not specify any parameters, so you know what you're supposed to do, then you can here and you can say, turn on the first arrangement block. So you can turn the visibility of this one to true, and logic true, but then you have to turn the other one off. because otherwise it will display both at the same time, and that would be awfully confusing. So now you have to remember to turn off the other one and specify this one's visibility to be off. Otherwise, the default is going to work just fine, so there's nothing you have to do. So let's check whether this works or not, right? So we go here, and it doesn't seem to be working. What is the problem here? The problem is this screen is already active, okay? So because it has been active all the time, it's not going to get reactivated. So that's why, it appears that the program is not working, but it really is working already. Okay.
Restart the program.
Sorry?
Restart the program.
Say again?
Restart the program.
We can restart the program. That is correct. We can. Is it the back button or?
Yeah, that works. Should work.
Actually,
Home. The home button. Two over.
say again?
Hit the home button, and then reach for your MIT companion.
Will it reconnect?
It should, yeah.
I don't think it reconnects. Okay, I think it will lose the connection. Let's see. Okay, I'm showing this one to be. One of them should be visible. It's turning off the other one, and then the other one is already by default turned off, I think. So let me do something here. Just to be sure that one is visible. So in this case, interactive is false, non-interactive is true. So let's go back, do this again. Nope. The app is still running. It's still running in the background, and that's why it's not working. If you long press the home button, there we go. When you long press the home button, you can see it's still running. So even if I click home and then long press the home button, it is still active. So it has not closed yet. The screen is still there. If I use the back button, that should fix it. But then App Inventor App Inventor would lose connection to it also. So I have to reset the connection at this point. I think I have to reset the connection. It doesn't know what to do with it anymore. So let's go ahead and I'm just gonna bite the bullet and reset it. But that's just basically hints for you guys. If you want to do it like this way using a client and a server app, which is kind of interesting, a way to organize your applications. This is one way to do it. And it's still starting up. But this time when it starts up, you should start it in the interactive mode, because the initialize block understands, oh, okay, I'm not started by another application. So, I'm going to get into the interactive mode. Yep. It started off in interactive mode. Okay. Are there any questions about this part? What about the part that debugs, okay, am I sending the right string, JSON encoded string to the other one? This is also what you can do. Within the server application, have screen one to do all the interactive stuff and the debugging part of it. You can also make a second screen to actually do the server stuff. Okay, so this is the actual server logic. And when you want to debug the application without an actual client application, now you can use screen one and use open another screen with start value to debug your application. In other words, instead of having C1 as a different application to use start activity and pass a value to server, you're now from inside server, one screen of server, to use this block open another screen with start value to debug exactly the same logic. If it works within server app itself, using the debug feature, it should also work from the other side. So you can now do most of your debugging using only one app and not using multiple applications. The other interesting part is you can actually start screen1 again. Does anyone know that you can start screen1 again? Okay, so that means you can within this block here. Okay, you can actually do the debugging like this. So if it is blank, at some point of this, you can use a start button. Okay, since I already have a start button somewhere, I can use it. So you can use a start button within the debug screen to use this block to start another screen, and that screen name turns out to be screen1, same screen that you're on. Okay, and it can nest it. You can actually nest, and when you do the back button, it will go back, in a nested way too. You can do recursion using screens. Yes. So here's an idea. I mean, this is really just an idea of what you can do with all this stuff here. You can take it a long way and make it make your applications complicated and organized in interesting ways. So are there any questions about this part of the lecture? This is really just kind of finishing up the discussion of how to use one application to start another one. But in this case, we are using App Inventor in both cases. Any questions about this part? Questions? Can anyone name one particular type of application where this might be helpful in having a server app and multiple clients to be basically just the front ends? E-commerce. Okay. What about tools like a level tool, a measuring tool, and stuff like that? Because you can store all the calibration constants into the server app. So no matter which client app you're starting up with, it will still retrieve the same calibration based on the device itself. So your length measuring one or your sound measuring one and whatnot, they will still be using the same calibration constants. And then each application does not need its own calibration process anymore. Right, so we are pretty much done with this one, and is everybody somewhat confident that you know what to do with your homework assignment? Okay, excellent. And I think that's the end of today's lecture. I will get this uploaded right away, so this way you can get started with whatever you need to do with today's lecture.